Hi everyone, my name's Michael and I'm Highways Operations Manager for Rochdale Council, and this is Leo from XAIS. Our presentation today is just outlining some work that we've done together on the management of road linings and markings. And the reason we thought it was useful to highlight this is we've taken a different process in producing our lining programme this year, and it's an approach that's given us loads of extra benefits in the way we've done things in the past. So originally, I came to XAIS with just a very singular objective, was that could they use existing lining data I have to produce a lining programme through the asset management software we have through them. What I actually came away with from that singular objective was these inputs. XAIS were able to implement a range of factors, some of which I didn't even know we had, to come up with a robust lining programme that not only met my original objective, provided me with other answers as well. So I'll introduce the process we went through as a local authority, and Leo will go through the technical detail on this. Yep. So to start with, we had three key stakeholders in this process. We had us as a local authority. We hold the maintenance responsibility, the decision-making power, and the budget to carry out these works. We work closely with lining contractors. They can provide us the raw information on condition and intervention, and they can undertake the works for us in the final programme. And then we work closely with XAIS, so they establish the method for data analysis and presented the outcomes to us in a useful programme that met the local authority and the contractor objectives. So straight away, this process worked for us really well. There were 5 key areas that we got additional benefit from as a local authority. The first one was risk-led programme. So all maintenance that we carry out on the highway is generally to improve safety, and if we don't maintain an asset, there can be negative consequences, and they can have a wide impact on several factors, including risk to service users, property, environment and other highway assets. And all maintenance decisions should be based on a review of risk or design with risk mitigation in mind. So using condition data as the main factor of maintenance is not really enough to reduce risk. Conditions should be used along with other factors to form part of the risk analysis. This was a real key benefit for me, was the integration of existing data that we had. XAIS were able to put existing data that we had into XA to inform this programme. So it not only increased the robustness of the decision-making process, but also increased the value for money as existing surveys that were being used for more than their original purpose. The key existing data that we had that XAIS were able to utilise was analysed accident data, scrim analysis, scanner data and other data attributes that we held, including AEI, and then IRAP assessments fulfilled most of the risk profile data collection requirements. Unlike other assets on the highway, lining programmes had never really been projection modelled in Rochdale. This process allowed us to look at not only the existing condition, but to take a long-term view on how the asset is likely to perform in the future. So a useful byproduct of this process is we can now develop condition projection models and lifecycle plans for an asset that has never been managed this way before in the past. Or we could also understand condition beyond the timescale of a single programme, and we can understand how the actions that we implement now will affect the asset in the future and how that will impact overall risk. We'll move on to scenario modelling. So the model that was developed can use a number of factors to model the effect of different scenarios. We can determine intervention frequencies, and they can be used to establish the effect on condition and overall risk. And we can feed in acceptable levels of risk that can determine how the intervention criteria will change. We can allocate finite resources such as budget, contractor availability, and that will allow the model to balance resources against intervention and levels of acceptable risk. And the programme then can be produced using any agreed level of intervention, acceptable risk, resource and cost. Then another key benefit here was live deliverables. Projection modelling can use pool data and can be updated as regularly as the data source is updated. So every time a condition, an asset or intervention data is changed, the model changes and then the outcomes are presented immediately to me. It provides a projection of condition, risk, cost or resource live, and then the deliverables are available to me through XA, which is the system that we use through XAIS. And then I'll let Leo talk through the technical side of this now.
Thank you, Michael. Okay, let's go to these 3 columns that are the base of our approach. I will try to do it succinctly. So we use patronets that have 4 main components. The components are the places, transitions, tokens, and arcs. With these, we base in the uncertainties that we have. So we use random variables to check the time that we need to go from one state to the next one, and we base that on our inspections. We use machine learning algorithms to fill some gaps in knowledge, especially when data is absent, and the condition projection curves now. We go from a process that is deterministic to a stochastic process because we use random variables, and we combine all of that to produce our projection curves. This formalism uses, as I said, the material properties of the roads, of the lines, and also when we don't have enough data, we can check from all of our authorities what combines more with the data that we have for a specific authority, in this case Rochdale, but it's always important to address and to assess the data that we have, and that's why it's important to have also expert opinion. So we can have curves for different types of features like retroreflectivity and wear index. Is exploiting the static patternette so we can have the condition plotted, but we can do more, because when we have our transitions between states modeled with random variables, we are able to understand the uncertainty related to that, and we can present curves that gives us the probability of reaching asset failure for distinct service levels as we present here. Once these service levels and respective probabilities were established, we could determine whether intervention frequencies or acceptable risk levels. We can, for example, employing a fixed 24-month refresh tells us the probability of reaching a barely visible line, and for this case is 60%. Risk mitigation includes risk identification, assessment, prioritization, and the response or the strategies to respond to risk. Risk assessment involves the likelihood and severity of the occurrence of accidents that might be affected by line conditions. The likelihood is influenced, for example, by the road layout, the condition, street lighting, lane number, and their width, while the severity is related to traffic flow, resistance of intersections, presence and distance to other assets at the roadside, and the operating speed. The definition of priorities was based on the line diagrams. Risk response and strategy is based on defining limit states and respective probability of failure thresholds. This process resulted in risk mitigation profiles for each line, which was part of the process but not considered the deliverable. We have this risk matrix that has a relationship between likelihood and severity. I would like to show you an example of a diagram which represents a double white line in a location where accidents are possible to happen and their severity is considered major. The condition considered is the retroreflectivity, and the service level is associated with a retro below 150. We can see that in this case something has to be done when after 1 year, when we reach a probability of 50%. And actually, close, let's see an example of alternating curbs that can obstruct the driver's view of oncoming traffic and road conditions beyond them. Without adequate lighting, visibility is further reduced during and non-daylight hours, making it more difficult for drivers to perceive and react to the road ahead. we can see in the example there is evident wear on one of the central lines. The operational speed here is 60 miles per hour, and we also have some other assets that can increase the severity of an accident. In addition, we also have an intersection for the access to agriculture field. So this is a short video where we can see the importance of those lines to increase the preview time for the driver and his ability to maintain the lateral position of the car. And those central lines are especially important because usually the lateral lines are covered with dust from the agricultural fields. So at the end, we have risk projections for the lines, not only the conditions. We know that we don't have operationally, we cannot intervene on a line-by-line basis. We have to acknowledge that we need to create clusters that represent groups of lines that for operational efficiency would be replaced at the same time. We focus more on junction areas for that specific traffic management requirements and logical operational boundaries are imposed. We have to be flexible as well and change on detrimental to model or deliverables, and we have to consider also the resource and cost information. Replacing clusters are needed. We know that about the risk profiles inside this cluster. Diagram numbers were assigned the driver value for critical or non-critical lines, and the cluster profile was determined by average of weighted critical and non-critical lines within the cluster. So finally, we have risk profiles and cost resource projections as well. The works program can be consulted through tables where our Mike can check the risk scores for each region and cluster. And finally, we have the complete approach that XAIS-PTS used to assist Mike and Rochdale to make the most of data collection through condition modeling, establishing risk profiles and risk projections while considering operational efficiency in our program.
Thank you, Leo. So, based on all the work then that XAIS undertook for us, I now have a risk-based lining works program that follows the guidance of the infrastructure code of practice. And I think you can appreciate the complexities of some of the data and that goes into this modelling. From a local authority contribution, I only really had to provide 3 key inputs. I provided data sets that we didn't have in XA. I agreed on some scenarios and service levels, and I agreed on some operational work areas. And that was all I had to put in. XAIS then provided the rest to give me this comprehensive lining program. And that finishes our presentation. So thanks everyone for listening. If you'd like any more information, we do have a stand over there, stand 53. But thank you very much, guys.